Guys, good day. I'll be treating differential equation, that's in EEE 231 chapter 6, differential equation. I'll go to example 1. We're going to form a differential equation from the function y equals to, let me write out the question. Let's write it out. Instead, let us form a differential equation from the function y equals to x plus a over x. Alright, I want to find a differential equation from this function. It's just simple. It's very simple. What is just expected of us to do is that we just say y equals to, okay, let me write this out. Now we can just bring this x to this side. That will be y minus x equals to a all over x, and afterwards you can just decide to make this one y minus x equals to, you can represent it like this, a x power minus 1. Alright, after you've done that, you can still decide to, is that you just make it like this, or you just cross multiply a, and that will be a equals to x open brackets y minus x. It's still the same thing if this x comes to this side. I hope you get that. Now we have to open bracket, that will be xy minus x square, and after opening the bracket, we have to now go for differentiation. We are now to differentiate. Now when you differentiate a constant, your a, it's simply 0, and when you differentiate x, when you differentiate your x, it will remain y. Your x is 1, so it will remain 1y, and that is still y. And when you differentiate your y, it will remain x, which means x. When you differentiate your y, it will be y, that will be dy dx. Instead of writing y, when you differentiate your y, it will be dy dx. Now minus, when you differentiate these also, that will be 2x. Yeah, that's just 2x. Let me rewrite that. 0 equals to x anyhow, y dy dx minus 2x. Simple. Now after you've done that, oh sorry, this is 0 equals to y x dy dx. I forgot the sign in the middle. After you differentiate x, it will remain x, it will remain y, and after you differentiate your y, it will remain x. So in that process, there's an addition sign in between all of them. I hope you get that. There will be an addition sign between them. Oh, let me just clear away this side. Sorry. Now that means my writing this equation, a is now 0. When you differentiate this, it remains y, you get, plus when you differentiate your y, it will remain x dy dx minus 2x. I hope this will clear our doubt. And after that, you can just collect the like terms. You can let this come to this side, and that will be, yeah, that will be 2x minus y equals to x dy dx. I hope you get that. 2x minus y equals to x dy dx, and that will be all for this equation. The derivative of this, a differential equation of the function y equals to x plus a over x, is this. Solving the example 6.2, that is, we're told to solve the differential equation differential equation, which is dy dx equals to 2x squared plus 4x minus 1. Yeah, this is what we have to solve right now. We have to solve this. Okay, so we have different methods in solving this. We have different methods in solving it. The first method is direct integration. We also have other methods that we can use to solve other ones. We have separating the variables. We have some other like that. We have homogeneous equation and the likes. We still get there. We still have integrating factor. We still have Bernoulli's equation. But right now we are dealing with direct integration using direct integration. So using this direct integration, that will be, we want to solve this differential equation. That means there will be integration involved in this, and let me just write it here. Dy dx equals to 2x squared plus 4x minus 1, and you can just say dy equals to 2x squared plus 4x minus 1 dx. You get that? Yeah, it's as simple as that. So the next thing that we have to do is just to integrate. When you integrate your dy equals to integration of this also 2x squared plus 4x minus 1 dx. Yeah, that's that. So when you integrate this, what does it give you? This will give you your y, and when you integrate this also, this will give you 2 over 3. X is power 2 plus 1, that will be x is power 3. That will be x is power 3. Yeah, so that will be 2 over 3 x raised to power 3 plus 4x squared over 2. Okay, 4x squared over 2, then minus x plus c. To furtherly do it, 2 over 3 x raised to power 3 plus 4 over 2 here will give you 2x squared minus x plus c. That's all under that. Alright, so we move on to the, okay, let's take one more example. Example 6.3, and the question says that we should solve the equation e raised to minus x dy dx equals to 4, given that y equals to 3 and x equals to 0. Now these are called the initial condition. Just note that the question says exponential minus x to y dx equals to 4. We have to solve this given y equals to 3 and x equals to 0. Alright, to do this, let's first of all get the derivative. To y dx equals to, if this is come to this side, that will be 4 exponential x. I think you understand that. Just like dividing both sides by exponential minus x or by exponential minus x, minus b plus, that will be 4 exponential x. Alright, so after you've gotten that, you can now say the dy, we are using direct integration method, so we can just say dy equals to 4 exponential x dx. Alright, afterwards we can now find the integration of both sides. That will be integral of the y, which is y, the integral of 4 exponential x is 4 exponential x plus c, yeah. So y equals to 4 exponential x plus c. Given that our y equals to 3 and our x equals to 0. So we can just say our y is 3. That will be 4. That will be 3 equals to 4 exponential. Our x is 0 plus c, and that will be 3 equals to 4 plus c, and that will be 3 minus 4 equals to c, which means c equals to minus 1. Yeah, c equals to minus 1. We can now go back to the equation and say, therefore we can now say y equals to, from this place, y equals to 4 exponential x. Now instead of plus c, that will be minus c. This is minus 1. Sorry. That will be y equals to 4 exponential x minus 1. Thank you. Yeah, that's correct. That was a mistake. I was right 1 here. Alright, so let's move on to the next method, that is separating the variables. Let me just demarcate this. Sorry, I'm managing my space. Separating the variables. Separating the variables. Okay, now the question says solve dy dx equals to, open bracket, 1 plus x 1 plus y. All right, now when you're talking about separating the variables, what you're just expected to do is just let these y's, the y's, let them be at the side, and the x's, let them be at the side. What am I trying to say? That means we want to find a way whereby this will be at this side and this will be at this side, so that everything here will be x and everything here will be y. And how do we do that? We can just say dy all over, when we divide both sides by like this, all over 1 plus y equals to 1 plus x dx. If you solve it very well, this is what you're gonna get. Yeah, that's what you're gonna get. Now after that, after you have made these ones be at the side, your 1 plus y and dy, everything at the side like that, you now find the derivative, integral of dy over 1 plus y equals to the integral of 1 plus x dx. Yeah, that is that. Afterwards, we can now say integral of 1 over 1 plus y, integral of 1 plus y dy equals to the integral of 1 plus x dx. Yeah, now when you want to the integral of 1 over 1 plus y is ln, that will be ln 1 plus y. So if I tell you the integral of 1 over x, that will be ln x. You understand? So the integral of 1 over 1 plus y is ln 1 plus y, and 1 plus y equals to the integral of this. Your 1 will be x, plus your x will be x squared all over 2 plus c. Yeah, plus c. That's all on that. We're done with this. Hit the subscribe button.